Hi, today we are going to discuss some of the problems related to solar radiation geometry. Before going to solve the problems, we have to know some basic concepts related to solar radiation geometry. Indian Standard Time is calculated on the basis of 82.5 degree east longitude in the city of Mirzapur, that is Uttar Pradesh, which is situated approximately in the corresponding longitude reference line. So here this value is important, 82.5 degree east. It is the standard time longitude. So the first problem is calculate the number of daylight hours in Delhi on December 22 and June 22, 1995. Here phi equal to 28 degree 35 minutes. So the location is given, that is 28 degree 35 minutes. This 28 degree 35 minutes can be converted to degrees, which is equal to 28 plus 35 divided by 60, that is 28.5833 degrees. We have to calculate the number of daylight hours. Before going to the calculation of day length hours, we know day length hours TD equal to 2 by 15 omega s. So we have to know the value of omega s. This omega s is sunrise angle, and the sunrise angle is related to the declination angle and latitude of the location by the formula cos omega s equal to minus tan phi tan delta. This phi indicates the latitude and delta indicates the solar declination. So here we have to find the value of omega s, and which is given by the cos inverse minus tan phi tan delta. Phi we know, that is 28.5833 degrees. So we have to calculate the angle delta declination. By Cooper's equation, delta equal to 23.45 sin 360 divided by 365 into 284 plus small n. The small n is here. First we have to calculate the number of daylight hours corresponding to December 22. Here in this problem, first we calculate the number of hours corresponding to June 22, 1995. For June 22, small n equal to 31 plus 28 plus 31 plus 30 plus 31 plus 22, which is equal to 173. Again, small n is the day of the year, and by substituting these values we will get delta equal to 23.4324 degrees, and we find the delta, we know the location, hence we substitute these values in omega s. So omega is equal to cos inverse minus tan the values. We will get the answer 103.657 degrees. This is the value of omega s. The day length in hours Td is given by 2 by 15 omega s, and while substituting the values we will get the answer as 13.82 hours. Similarly, we can calculate the duration of daylight corresponding to December 22. The same procedure. N will change. Small n is the day of the year. For December 22, the value is 356. Substituting the values in Cooper's equation, we will get the answer minus 23.445 degree. Then sunrise angle omega is 76.33 degrees, and we will get the answer as 10.178 hours. Now the second problem. Calculate the hour angle when it is 3 hours after solar noon. Here omega is the hour angle. At solar noon, omega equal to 0. Each hour angle equates with 15 degree of longitude with morning, which is taken as positive, and afternoon, which is taken as negative. For example, if 11 a.m., then omega equal to plus 15 degree. Suppose 1 p.m., then omega equal to minus 15 degree. We can calculate with another formula. Hour angle omega equal to 12 minus st into 15 degree, where st is the solar time. Here 3 hours after solar noon, hence solar time equal to 12 plus 3, which is equal to 15. While substituting the value of st in this expression, we will get omega equal to minus 45 degree. Negative sign indicates the afternoon. Another problem. Calculate the hour angle when it is 2 hours 20 minutes before solar noon. Again the same formula. Here solar time equal to 12 minus 2 hours 20 minutes. 12 minus 2 plus 20 by 60, which is equal to 9.67. Substituting the value of solar time in the equation of omega, we will get the answer 12 minus 9.67 into 15 degree, which is equal to 35 degree. Positive sign indicates forenoon. Again, I am repeating. For solar noon, omega equal to 0. Omega is the hour angle. It is positive between solar midnight and noon, and it is negative for other case. That is from noon to midnight. Another problem. Calculate zenith angle of the sun at Lucknow, that is 26.7 degree north, at 9:30 a.m. on February 16, 2012. We have to calculate the zenith angle. Zenith angle is the complementary of sun's altitude angle. It is a vertical angle between sun's rays and a line perpendicular to the horizontal plane through the point. That is angle between the beam from the sun and the vertical. A relation is given by cos theta is equal to cos phi cos omega cos delta plus sin phi sin delta. The latitude of the location is given, phi equal to 26.75 degree. We have to calculate the other values and substitute in this expression. Omega, as you know, it is hour angle. The same expression, 12 minus st into 15, that is 12 minus Solar time is 9:30 a.m. The earlier case, we have calculated the solar time. Similarly, we can calculate the solar time in this case also. And when we substitute in the equation, that is omega, we will get the answer as 37.5 degree. Again, we can calculate the value of delta by using the Cooper's equation. We can calculate the value of small n, it is February 16, and we will get the value of delta is minus 12.95. By substituting these values in this equation, we will get the zenith angle theta z. And if we want to find the, or if the problem, if they ask us to find solar altitude angle or solar inclination angle, it is alpha. That is, I have already mentioned, both are complementary angles. This altitude angle and zenith angle, that is alpha plus theta z equal to 90 degree. And if we want to find solar inclination angle alpha, then take 90 degree minus theta z. So first we have to calculate the zenith angle, and 90 degree minus the zenith angle gives the inclination angle, solar inclination angle. Then another problem, determine the local solar time and inclination at a location latitude 23 degree 15 minute north, longitude 77 degree 30 minute east at 12:30 IST on June 19. Equation of time correction is given from standard table or chart, which is equal to minus 1 minute 01 seconds. This local solar time is given by the expression standard time plus or minus 4 into standard time longitude minus longitude of location plus equation of time correction. Here standard time, it is given as 12 hour 30 minutes minus, this negative sign is applicable for the eastern hemisphere, 4 into standard time longitude, that I have already mentioned, 82 degree 30 minute, in the city of Mirzapur, Uttar Pradesh, 82 degree 30 minute minus longitude of the location is 77 degree 30 minutes minus equation of time correction. General formula, it is in the plus sign, but here the equation of time correction is minus, so we have to put this minus sign here. 1 minute 01 seconds. Another factor is this local solar time. The correction has a magnitude of 4 minutes for every degree difference in longitude. This is standard time longitude minus longitude of the location. 82 degree 30 minute minus 77 degree 30 minutes. This minutes, if we convert it into degrees, then 82 plus 30 divided by 60. This 77 plus 30 divided by 60. Taking the difference, we will get the longitude difference as 5. Here it indicates that for every degree difference in longitude, the correction has a magnitude of 4 minutes. Here the degree difference is 5. Hence, the correction has a magnitude of 4 minutes. So 4 into 5, which is equal to 20 minutes. So 12 hour 30 minutes minus 20 minutes minus 1 minute 01 second. If we take the difference, just calculate. If we subtract 12 hour 30 minutes and 20 minutes and 1 minute 01 second, we will get the answer 12 hour 8 minutes 59 second. Then again, declination theta can be determined from the Cooper's equation. Then n is the day of year, and finally we will get the answer as 23.43 degrees. We can convert the values into minutes and seconds. Otherwise, just write the step as our final answer as 23.43 degree. Then another problem, calculate the angle made by beam radiation with normal to a flat collector on December 1 at 9 am. Solar time for the location is 20 degree 35 minute north. The collector is tilted at an angle of latitude plus 10 degree with the horizontal and is pointing due south. Here collector is pointing due south, hence the value of gamma is 0. Again, declination can be calculated from the Cooper's equation. We can calculate the hour angle omega corresponding to 9 hour. And finally, cos theta t equal to this case, for surface facing the south, gamma equal to 0, cos theta t equal to cos phi, cos delta, cos omega, cos s minus sin delta, sin s. Or we can simplify the expression as sin delta, sin phi minus s plus cos delta, cos omega, cos phi minus s. We'll get the final answer theta t as 44.72 degree. This is another problem. Determine the average value of solar radiation on a horizontal surface for June 22 at a latitude of 10 degree north if the constants A and B are given as equal to 0.30 and 0.51 respectively, and the ratio n bar by n equal to 0.55. H0 is the monthly average horizontal solar radiation for a clear day. H0 can be calculated by the equation 24 by pi ISC 1 plus 0.033 cos 360 n by 365 cos phi cos delta sin omega s plus 2 pi omega s by 360 sin phi sin delta. ISC is the solar constant per hour, N is the day of the year, omega s is the sunrise hour angle. We have applied the same concepts that we have studied earlier and just by substituting this final expression we will get an answer like this: 24 by 3.14 ISC 0.9816. The value of ISC in SI unit is 1353 watts per meter square, or 4871 kilojoule per meter square hour. In MKS units it is 1165 kilocalorie per hour. And by substituting the value of ISC we will get the final answer. These are my references. Thank you.